let's look at the join conditions, especially the columns involved in join conditions in further detail. So far in this course, actually, throughout this course, all the joins will be performed on columns with the same names from different tables. This is called natural join, which means different relations will join each other on a same attribute with the same name. Of course, when you join relations, you do want to join on the same attribute, right? The only when they have an attribute that means the same thing, then these two relations can be joined. However, different relation may have different names for the same attribute. Telephone number, for example, some people will put a telephone number. Some people will put a phone number. Some people will put a phone, just phone. Or some people will just put the phone, NO. So these are the same thing. And if you want to join, however, different relations may have different names. And when you have something like this is no longer called natural join. SQL does allow you to perform joins on columns with different names or multiple columns. This is more common in real world. So let's look at both scenarios. The first scenario is if you want to join on multi-columns. Usually that's when you have a key of multiple columns. For example, if you want to join, like we have the, like usually in the soccer game, for example, you have the starting date and the time. These two can be two different columns. If you want to join this game to some other game information, then you will be joining first on date and on time. And here, this and is a real and. Both date and time must match between these two tables. So what you are going to do is when you have a from table 1 joining table 2, you will have an on clause with matching column 1 equals to matching column 1, then followed by the and keyword, the logical operator of matching column 2 and matching column 2. These two conditions, column 1 matching and column 2 matching, both must be satisfied in order to join. So that's why you need an and. Now, I know you are probably thinking, can I use an or? And usually we don't do that. The reason is join is associating different data sets. And when you try to do this join, you always want the join to be deterministic. You want each row has a fixed corresponding row in another table. You don't want these two, you don't want to come up with a bunch of rows that can satisfy, that the condition can come up with several rows, or none of them is determined. So usually we'll just do it on with an and condition. However, there is instead of equals, you do have the ability to use other conditions like greater than or less than or between. All this is called a non-equal join. In a non-equal join, you will associate two tables with non-equal operators like greater than or less to or between and end. The most common scenario is in what we call a slow changing dimension, which means the value change over time. For example, coupon. This is very common, right? Coupon, when you buy something from a store using a coupon usually have effective date and termination date. It's only usable inside these two dates. So if you want to calculate the actual price by applying the coupon, probably by original price times some percentage, you not only need to check the coupon code, you also need to check the transaction date. You want to make sure the coupon ID equals to coupon ID, as well as the transaction date between the transaction table's transaction date is between the coupon table's effective date and termination date. So this is what we call non-equal join. And other than between and, you can also have greater than or less to, depends on your exact scenario, right? So, but here still, as we said, join must be deterministic. So it's still an on one condition and another condition, right? So this is non-equal join. And with a non-equal join, you can clearly see that even in the condition, these three columns are all different, right? They are not as, they don't have the same name. That's apparently not natural join. And even in an equal to condition, SQL allows you to use different column names. So SQL can match table on columns with different names, where you will just put from T1 joining from table 1 join table 2 on. Column 1 equals to column name 2. And here, note that I'm not putting table alias or table name. Why? Because if the table names are, if the column names are different, there's no ambiguity. SQL should be able to tell which column comes from which table. So that's why I did not put table name as a qualifier for the column name. However, in real time, in real world, it's still a best practice to use table alias on all columns, no matter whether it's required or not. Because when you write the SQL, usually you really don't know, or you are not clear whether there are like ambiguity in the name or not. Of course, you know, because those are key. You already know that the joining columns, joining condition columns have a different name, but it's highly possible that there might be some name in table 1 or table 2 that it will change. It will have the same name. A very common example is just ID. Maybe you are joining ID with maybe in table 1 you have ID, and table 2 you have a number which actually should join into ID, and you have another column called ID which is of a different meaning than ID in the table 1. And this can be messy. This sounds messy. I know it sounds messy, but these are things you will run into in real world. So as a data scientist, you need always be careful, always be prepared that you are getting a messy table. So writing table alias is one good practice that you should always do.